Hey everybody, welcome to section 3.2 on triangle congruency. So first let's talk about the definition of congruent polygons. Two polygons are going to be congruent if and only if their corresponding parts are congruent. So all their angles have to be congruent and all of their sides have to be congruent. So in this example here we have two triangles, ABC and HJK. So notice how the angles are marked congruent. So angle A would be congruent to H, B to J, and C to K. And then the sides are AB has one tick mark and HJ has one tick mark. BC has two, JK has two. AC has three, and HK has three. So all those sides are congruent. Now the congruency statement is telling you which triangle is congruent to which one. So when you write your first triangle, the order that you write the first one in is absolutely, completely 100% up to you. The second one, it is no longer up to you. You have to follow the same order of correspondence that you wrote the first triangle. So for example, this first congruency was written A, B, C. Triangle A to B to C. So the order, I like to think, okay, I traveled down the one tick mark path to two tick marks. So then when I write my second congruency, I have to do that exact same thing. One tick mark to two tick marks. So here it would be HJK. Now this picture is color coded for you, so it makes it easier. However, it's not always going to be that way. So for example, let's say instead I wrote triangle BAC. If I wrote triangle BAC is congruent to which triangle? Well, here I went one tick mark to three. So I would have to take that same path for the second triangle, 1 to 3. Or you could look at it as far as angles are concerned, like double, single, triple, think of it that way. So then BAC is going to be congruent to JHK. If you look back to my original statement, if it was ABC, I now wrote it, if I think of it as the first letter, second letter, third letter, let's say, and then first, second, third. When I wrote BAC, my order is 2, 1, 3, if you follow what I mean. It's where A is 1, B is 2, C is 3. So then I would have to do the same thing for the second triangle. It'd have to be 2, which was J, 1, which is H, K. I'm just trying to say that as long as you keep the order consistent, you can write these triangle congruencies in a few different ways. So, as I just said, other ones exist. As long as they match up with colors, it's a lot easier. But like here, ABC does not match up to HKJ because this congruency statement, when it's correct, without even looking at a picture, I would know angle B is congruent to angle J. How do I know that? Because B is the first letter of my first valid congruency statement. J is my first letter in the second one. Angle C, I would know automatically, is congruent to angle 8K. And that's why it's important to be careful and write these in the correct order, because then your congruency statement tells you a lot of things. Another thing it tells me, BC is congruent to JK. I don't even have to look at the picture. Because this congruency statement is valid, I know for sure that those two segments are congruent. I would know BA, that segment, is congruent to JH as long as it's the same order. If this is confusing, I'm sure we'll go over it in class in a little bit more detail in person and hopefully clarify any confusion. Okay, CPCTC. So the phrase if and only if in the congruent polygons means that both the conditional and the converse are true. So if you remember, we did this last chapter. In all definitions, any definition in geometry in any math class is always biconditional, meaning the converse and the conditional are both going to be true statements. So if two polygons are congruent, then their corresponding parts are congruent. For triangles, what we would say is corresponding parts of congruent triangles are congruent, or CPCTC. I always tell my students to remember this by the phrase, cool people can take calculus. So that doesn't stand for cool people can take calculus. It means corresponding parts of congruent triangles are congruent. So if I know that two triangles are congruent, I know all their parts are congruent. All three angles are congruent. All three sides are congruent. All right, so let's use some CPC-TC. It says we have triangle JKL is congruent to RST. Then they give us a bunch of segment lengths, and we're going to draw and label a diagram for the congruent triangles, use tick marks to show the corresponding sides, then we're going to find X and Y. So the first thing I'm going to do is draw two triangles. I don't know what kind of triangles they are as far as sides, as far as angles, so I just draw two triangles. Now if they told me JKL, I'm going to go JKL. How did I know that? I didn't. I could just label it any way I want. That is my prerogative. It's my choice. But now the second triangle, I want it to be in the same order as the first one. So because I put J in the bottom left corner, I'm going to put R in the bottom left. Then I went up to K, I'm going to go up to S. I went down right to L, now I'm going to go down right to T. So I'm going to mark the sides that are congruent with tick marks. So JK is congruent to RS. JL is congruent to RT, and then the third side, KL, is congruent to ST. Next, I'm going to fill out what they gave me. They told me RS is 7, ST is 5, RT is 9 plus X, JL is 2X minus 10, and JK is 4Y minus 5. So I have to find X and Y. So I see here that JL is a segment that has X in it, so is RT, and I know that those two are equal. So I'm going to set up an equation that sets those two segments equal. 2X minus 10 is going to equal 9 plus X. I'm going to go and solve this for X. I get X minus 10. If I subtract X from both sides, I get X minus 10 equals 9. Add 10 to both sides, X is going to equal 19. To solve for Y, I'm going to do the same thing. I see that JK here is in terms of Y, so SR is going to be equal to JK. So my setup for that one is going to be 4Y minus 5. Oops, that's not a pen. 4Y minus 5 equals 7. Add 5 to both sides, I get 4y equals 12, and y is going to equal 3. So now you might be asking, well, what about this 5 over here? Who cares? We don't need it. We didn't use it because we don't have any expression for KL. Okay, so x is 19, y is 3. Okay, so there are 5 different triangle congruency theorems that are going to allow us to determine if triangles are congruent. And the 3 are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So in red is the abbreviated way that we write those. We don't have to write side, side, side every time. We would write SSS. So let's go ahead and talk about what these 5 different theorems mean. So side, side, side means if you have 3 sides of one triangle and they are equal to 3 sides of another triangle, then the 2 triangles have to be congruent. Okay, so if I gave you 3 different lengths, let's say I gave you a pencil, a pen, and a piece of chalk, and everybody got the same exact pen, pencil, and piece of chalk, every single person in the class would create the same triangle. If we were to create them on our desks, everybody's triangle would be exactly the same. There's no possible way that somebody could have a triangle that's a different size. It might be flipped, it might be upside down, but they're exactly the same. I take one, I put it on top of the other, they're perfectly aligned. The second theorem, side angle side, says that if we have 2 sides and the included angle of one triangle, and they're congruent to 2 sides and the included angle of a second triangle, then the triangles are going to be congruent. So what's important here is when you have 2 sides congruent, the included angle means the one that's in between the 2 congruent sides. So in the first triangle, it would be angle B. The second triangle would be angle E. Say that I marked AC congruent to FD. C would be the included angle of these 2 sides. F would be the included angle of those 2 sides, the double tick, triple tick. Okay, so the included angle has to be the one that's formed by the 2 congruent sides. So again, say I gave you a pencil and a pen, and I said the angle between the pencil and the pen has to be 20 degrees. Put those 2 pieces together, the pencil and the pen, make a 20-degree angle between them, and then draw on the third side. Every single person would have the exact same triangle. There's no way to draw a triangle that's different. All of the triangles would be congruent. Okay, angle side angle is that if you have two angles congruent, so like in the first picture, triangle ABC, we have angle A and angle B. The included side would be AB. It's the side between those two congruent angles. And then in the second triangle, notice we have two congruent angles. So B and E are congruent, A and D are congruent, the sides between them are congruent. Then every single person, if we were to draw these triangles, we would all have the exact same triangle. Those would be congruent. So again, angle, then a side, then an angle. It has to be in that order. Angle side is if you have, in this case, angle A congruent to angle D, angle B congruent to angle E. Notice the side then is the non-included side. It's one that's not between the two angles. So we drew BC and EF. It could have very well been AC and DF. Those two segments would have been okay too. That would have still been angle, side. Here, angle, side. And you have to kind of go in order. You would never label this when you are going to be labeling these triangles. You don't jump around the triangle, so you wouldn't say angle, then a side, then an angle. Okay, because angle, side, angle is different than angle, side. You kind of have to go in order without, you go clockwise or counterclockwise around the triangle. And you do that when you're trying to figure out by which theorem the triangles would be proven congruent. Okay, hypotenuse leg. Because it's hypotenuse leg, it's only can be used if you have a right triangle, because other triangles that aren't right triangles don't have a hypotenuse. So it wouldn't make sense to use this theorem if your triangle isn't right. So what this theorem says is if you have the hypotenuse and leg of one triangle and they're congruent to the hypotenuse and leg of a second right triangle, then the triangles have to be congruent. And notice here on the bottom, it can only be used if you have established that the two triangles are right triangles. Because if you were to there is no side angle congruence, right? This is a side angle if I don't jump around, if I go in order, and there is no side angle congruence for triangles that aren't right. And if there is, we call it the hypotenuse leg. So you would have a hypotenuse congruent to a hypotenuse, and then a leg congruent to a leg. That is the only time you could use hypotenuse leg. Now, another thing I want to point out is just because you have right triangles does not mean it's automatically hypotenuse leg, because it doesn't have to be. It could be something else. But if you're going to use hypotenuse leg, that can only be used for right triangles. So if it's a right triangle, there's a chance that they're congruent by hypotenuse leg, but it's not guaranteed. You have to check what congruencies you have. Okay, so we're going to practice using these theorems to prove triangles are congruent. So for the pairs of triangles on the following slides, we're going to use the given information and mark the diagrams with the appropriate tick marks for sides, arcs for angles. If the triangles are congruent, we're going to write which congruency theorem, the 5 that we just learned, side, angle, side, angle, side, hypotenuse leg. If none of those theorems apply, we're going to write not congruent. And then finally, if they are congruent, we're going to write a congruency statement. If they're not congruent, you cannot write a congruency statement. It doesn't make sense to say what's congruent to what if they're not congruent. Okay, so here we are given some information. They said RT, that ray, bisects QS. So if I said, what does that mean that this ray right here, RT, and I'm using blue when I should be using a different color, RT, this ray is bisecting QS. Hopefully you're all thinking, okay, well that splits QS into 2 equal pieces. That's what bisecting means. So I would add a tick mark here and a tick mark there. So that shows we have at least one side congruent so far. Second, we are told that QRS is an isosceles triangle with a base of QS. If this is the base, right here, QS is the base, that would mean that QR and RS are the legs of this triangle, so the legs of an isosceles triangle are congruent to each other. So far I have 2 sides. So if I'm thinking of my 5 congruencies, SSS, SAS, ASA, angle, side, AAS, and then hypotenuse leg, my only 2 that this might be right now is side, or side, angle, side. I don't have any proof that these are right triangles. You don't go based on looks. Just because it looks like RT is perpendicular to QS, we don't have any actual information to back that up. If I had to argue in a court or in front of, in front of a judge and say that is perpendicular, they'd say, how do you know? And I'd say, well, I don't know. I can't say because it looks like it. So that is not a valid argument. So therefore I can't say, oh, those are right triangles. Instead, what's going to happen a lot of times, something that's happening in this picture, and you're going to, become better at this as you practice it, this side of the triangle, TR, is congruent to itself. They share that side. I put them back to back. That's as if I had a pencil that's being shared, and then I drew two other congruent sides kind of from there, I guess. So therefore, I have marked all three sides of one triangle congruent to all three sides of the second triangle. So these triangles are congruent by side, side, side. Now comes my congruency statement. Triangle. I could start with the left triangle. I could start with the right triangle. That's totally up to me. And then with whichever triangle I start with, I can go in whichever order I want for the first one. I have a lot of freedom when it comes to writing my first triangle. Let's say I wrote RQT. Okay, no one can tell me that that's wrong. Now, when I write my second triangle, this is where I could potentially make a mistake. So I have to be careful. I have to write it in the same order. So how I do it in my own head is I think, okay, I started at R. I'm traveling down the double tick side to the single tick side. I have to do that same path for the second triangle. So I start down the double tick to the single tick. So it would be R, S, T. Now, any combination of this, like if I wrote QTR, that's okay. But then QTR, so what I did here is start at the middle, go to the end, hop back over to the front. I would have to take that same path for the second triangle. So start in the middle, go to the end, hop back to the front. So that would be congruent to STR. What if I wrote triangle TRQ? TRQ would have been congruent to, so I started at the back, so T, went to the front letter, the first letter, R, and then the middle letter, S. Okay, these aren't the only two other options. There are many, many more, but I just want you to know that there are many ways to write the first triangle. And then you have to follow in the same order for the second triangle. You have to go in corresponding order. Okay, so here we are given some information that we have to mark in the diagram. C is the midpoint of BD. So again, if C is the midpoint of BD, that means C is right in the middle of this segment. What does that make congruent? It makes this segment, DC, congruent to BC. Okay, so that's using my first piece of information. The second piece of information, they told me angle A is congruent to angle E. Okay, now I need one more. These are not right triangles, so I need three congruencies. When I see a picture like this, I call it the bow tie problem. It kind of looks like a bow tie, maybe off to its side. Anytime you have a bow tie problem, we're going to have vertical angles that are congruent. This is still true from chapter 1 when we learned about vertical angles. Vertical angles are still congruent. So now we have to decide which congruency theorem is being shown here. I'm going to write them out again. Hypotenuse leg isn't even a choice because we don't have right triangles for sure. So here, if I have two angles in a side, I know that it's going to be this theorem or this theorem. How do I know which one? Well, I have an angle, then a side. For angle, side, angle, what would have to be true is AC would have to be congruent to CE, and we don't have that. We have an angle, and the non-included side. It's not the side between the two congruent angles. So therefore, it's angle, angle, side. Okay, I could write my first triangle however I want. This is my choice. I could do the top triangle, I could do the bottom triangle. I'm going to write it as DCA is congruent to. Now the second triangle, I have to follow that same path. So I went D to C to A. So I like to think of this as, now I'm going to look at angles. I went no angle marking because D has no angle congruency inside of it. to double arc to single. So if I do that for the second triangle, that would also be nothing marked in the angle, double, single. And so that's my congruency statement. That's not the only one. As I said, there's many that I could write here, but that is just one of the many. Okay, given that B is the midpoint of AC. So here's AC. If B is the midpoint, what I know automatically is that AB is going to be congruent to BC. That is the definition of midpoint. It is in the middle of a segment. It splits the segment into two equal pieces, and so on. Okay, the next piece they're telling me is that EA is perpendicular to AC. If I know that two segments are perpendicular, what that means is I know they intersect to form 90-degree angles. So EA being perpendicular to AC gives me a right angle in the top left corner, and then DC is perpendicular to AC. So that gives me a right angle at C. And then the last piece of information they gave me is that BE, segment BE is congruent to BD. And there we have it. Okay, side, 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 no. Are we going to use side angle side? Not side angle side either, because remember, side angle side means you have two sides and then the angle between them. So that would have to be this angle and this angle. We don't have that. So it's not side angle side. Is it angle side? No, I don't even have two angles congruent. Is it angle side angle? Again, I don't have two congruent angles. So the only option is it might be hypotenuse leg. And for this one, if a triangle has a right angle, that's called a right triangle. So I know that triangle ABE is a right triangle, and I know that triangle BCD is a right triangle. So therefore, we have to decide, is this hypotenuse leg? Because again, sometimes triangles are not congruent, so it doesn't have to be hypotenuse leg. How do I tell if it's hypotenuse leg? The hypotenuse here is congruent to the hypotenuse of the second triangle, and we have a leg congruent to a leg. So therefore, it is hypotenuse leg. All right, let's write a congruency statement. Triangle, let's say we went ABE. It's going to be congruent to triangle. If I went A to B to E, I'm going to take that same path. It has to be corresponding. It's going to be CBD. Okay, you should be ready now for the 3.2 classwork. We will practice these. They do take a little bit of practice because it's something very kind of unique that you haven't done before, where you're marking these figures and trying to figure out how the triangles are congruent, if they are. So hopefully practice will make perfect. All right, thank you so much for watching. Have a great day. Bye.